Hiya, after a short break, I am now back with another question. And this time around, without exception, this is from another step paper. So, you have a triangle with side lengths p minus q, p, and p plus q, and you are given this information. You are also given that the largest and the smallest angles are alpha and beta, and you are asked to derive this identity. They also instructed you to use the cosine rule, so this is very nice of them. But first off, how does it look like in the first place? Because P is greater than Q is greater than 0, P plus Q would be the longest side, and P minus Q would be the shortest side. So if I am to make a sketch, this will be P plus Q, this would be P minus Q, and this would be P. Okay. We know the largest angle of a triangle is alpha. The largest angle is always opposite the longest side. And likewise, the smallest angle is always opposite the shortest side. You're asked to use the cosine rule to derive the expression. So, let's get to it. If we just look at alpha, p plus q squared is equal to p minus q squared plus p squared minus 2 times p minus q times p times cos alpha. We're just using the cosine rule with alpha. And therefore, rearranging this will give you an expression for cos alpha. This looks a little convoluted, so we shall see if we can simplify this further. Okay, we may be making a bit of progress here. So we are left with p squared minus 4pq divided by this mess, factorizing p from the top, and this gives you p minus 4q divided by 2 times p minus q. We are going to derive a very similar expression for cos of beta, and then we cross our fingers that we actually get the identity that they asked us to prove. So, cos of beta, p minus q squared is equal to p squared plus p plus q squared minus 2p times p plus q times cos of beta. So cos of beta is therefore this long expression. And as we have done above, it seems like we should be able to simplify this somewhat. They cancel out. Okay, we can take the p out from upstairs. Second part, done. Now we want to put this together to derive the identity. So, the goal here is probably to show that both left-hand side and the right hand side will give you the same expression in terms of P and Q. So let's do that. Left hand side. Just double checking that I got the right expression. Yep, all good. Okay. 1 minus cos alpha, that is P minus 4Q divided by 2 times P minus Q. Simplify this even further. Be careful with the negatives. Okay, so this is not too bad. Is there anything else we can simplify? I guess we can just leave it as is. Now we're going to tackle the right hand side. The right hand side is cos alpha plus cos beta. A lot of this is straight algebra. This is not even hard. It just takes a lot of time. We can now see the answers appear right in front of us. Factorize the 2 out, we have a difference of square. Et voila! We have successfully obtained the first expression. So that's part A of the question done. Not very complicated. Part B. In the case that alpha is equal to 2 beta, okay, now it's getting much easier because you can just take this result, replace alpha with 2 beta, and see what happens. You're then asked to find cos of beta and then find the ratio of the lengths of the sides. The rest of the question should be quite straightforward now. Left hand side would become, and the right hand side would become. Okay, what can we do? Where do we go from here? I would like to find a way to simplify this. I'm not entirely sure which direction I would like to go for now. If we look at the right hand side, we have cos of 2 beta plus cos of beta. Cos of 2 beta if we put it as 2 cos squared of beta minus 1, we can factorize the right-hand side. So that would give us 2 cos beta minus 1 cos beta plus 1. So let's just use cos of 2 beta is equal to 2 cos squared of beta minus 1, because this seems to be the most straightforward way to get to the final answer. This equation now becomes and the reason why I suggested doing this is because if we factor the 2 out from this, we would get 1 minus cos squared of beta on the left-hand side. Factorizing the right-hand side, that would give you cos beta plus 1 to cos beta minus 1. We need cos beta plus 1 on the left-hand side. Luckily, we have a difference of squares. 1 minus cosine squared, that is 1 minus cos, 1 plus cos. So we can bring the right-hand side to the left-hand side, then factorize. Do not ever cancel out the 1 plus cos beta. I will find you and I will whip you, literally. Factorizing this out, you're left with 8 minus 16 cos beta plus 8 cos beta squared minus 2 cos beta plus 1 equals 0. Et voila. From here, you can write down the possible values of beta, or rather of cos beta. So cos beta is either negative 1, 3/4, or 3/2. Since you are asked to show that this is the only appropriate value, you need to explain why you cancel out the other two. First case is quite simple. If cos of beta is equal to negative 1, that means beta has to be pi radians. If this is the case, but also remember that alpha and beta are angles in a triangle. So if beta is equal to pi radians, the other two angles do not exist. So we have to reject it. Similarly, cos of beta is equal to 3/2. Well, from here, you should already know that we have no real beta, because cos of beta is always bounded between negative 1 and 1. In this case in particular, you cannot even have it equal to negative 1 or equal to 1, because the angles must be non-zero. Therefore, cos of beta is 3/4. Now, let's just tackle the last part of the question. find the ratio of the lengths of the sides of the triangle. So we got an expression for cos of beta earlier. We need to set this equal to 3/4. Notice also that the sides were p minus q, p, and p plus q. This equation will give you the relationship between q and p. Find q in terms of p, plug it in, get the ratio. Simple as that. So let's solve this equation, shall we? P is equal to 5q. Therefore, p minus q, that is 4q. P, that is 5q. P plus q, that will be 6q. And therefore, the ratio of the sides is going to be 4 to 5 to 6. And this is the end of a question on a stat paper that was supposed to take you half an hour. Hope you find it useful.